Hello student, very good morning to all of you. I hope you all are happy, healthy and fine at home. Do you remember what were we discussing yesterday? I think we were discussing about aldol condensation, and as we know that aldol condensation means what? There are three different aldol condensation reaction occurs. Number one is called as a simple aldol condensation reaction. In simple aldol condensation reaction means what? The same molecule containing carbonyl group of aldehyde or the ketone 2 must have alpha hydrogen atom in presence of dilute alkali condensed together, and there is a formation of the carbon-carbon new bond is known as simple aldol condensation. And according to that we are getting the aldol is a product, and that aldol is a very unstable, and it just heat it, there is a elimination of the water molecule takes place, resulting into alpha beta unsaturated aldehyde or the ketone is a very stable compound, and whatever compound, resulting compound, the common name of that compound is a chalcone. So that are the thing we have seen. And now second one is a cross aldol condensation reaction. In a cross aldol condensation reaction, we have seen there are some drawback or the limitation of the cross aldol condensation reaction, as well as there are some very useful, or what we can call it as a benefit, or which is a beneficial for the organic chemist, in the sense that, let us see here, suppose both the carbonyl compound, because for cross aldol condensation reaction two different molecule, aldehyde or the ketone having at least 2 alpha hydrogen atom, if both the carbonyl compound has alpha hydrogen atom, 2 alpha hydrogen atom, reaction takes place that undergoes as a cross aldol condensation reaction, but we are getting number of or mixture of the product, 4 different condensation product we are getting, aldol product we are getting. For example, 2 are the self aldol condensation reaction, 2 are the cross aldol condensation reaction, and therefore there is a difficulty in the separation for such a type of the product, and therefore the scientist Aldol is discovered the new very good method for the synthesis point of view. What he did, there are certain criteria he found out. The two reactor he has taken of the carbonyl group, maybe as aldehyde or the ketone, and one of them, the reactor, there is no alpha hydrogen atom like formaldehyde or the benzaldehyde. And in the second key point in cross aldol condensation reaction, he has taken as only one of the carbonyl compound which has at least 2 alpha hydrogen atom, and then that molecule in presence used as a catalyst. And in the third point regarding that cross aldol condensation reaction, the carbonyl compound is added to this reaction mixture slowly, resulting into the condensation reaction, result into as a condensed product, which after elimination of water gives the alpha beta unsaturated compound, that is a alcohol, and that is called as a cross aldol condensation reaction synthetically. That is a very useful. For example, yesterday also we have seen some of the example, and today what we are going to learn, today we are going to learn about the intramolecular aldol condensation. That is the important point we are going to learn today. Intramolecular aldol condensation. Intramolecular aldol condensation reaction. Today we are going to learn about the intramolecular aldol condensation reaction. What does this word suggest? The intramolecular word suggests that intramolecular means what? The reaction takes place or reaction occurs within the molecule, because that the same molecule which containing as a 2 carbonyl group within the molecule and reaction takes place. So that type of the reaction is called as the intramolecular aldol condensation reaction. And synthetically, this intramolecular aldol condensation reaction, both the carbonyl groups are present in the same molecule, and there is a formation of the carbanion, and then condensed together there is a formation of the ring compound. And for a ring compound, such type of the synthesis is very important as far as synthetic organic chemistry is concerned, because that ring compound formation of the cyclic compounds is a very important as far as the organic chemistry is concerned. And therefore this is a very good example of that intramolecular aldol condensation reaction. If both the carbonyl groups are present within a single molecule, intramolecular aldol condensation reaction is possible, which would always lead to the formation of the ring compound. And hence synthetically very important, intramolecular aldol condensation takes place if the ring formed is either 5-membered or the 6-membered ring. Let us see here example is such type of the example. Here we are going to see, suppose here CH3, I am writing C double bond O as a specific point of view. Here C double bond O and here CH3. Both the carbonyl group are present within the molecule. Let us see here, if you number these 1, 2, 3, 4, 5, 6 and 7. There are the 7 carbon atom, not 7 carbon atom. Let us see over here again one more. Let me increase one more carbon atom over there. Here C double bond O and CH3 I am writing like this. Look at here, carbon number 1, 2, 3, 4, 5, 6, 7 and 8. And the name of this compound, the carbonyl group, they are present at 2 and 7 position. The name of this compound is a 2,7 octane diol. 2,7 octane dione. 2,7 at 2 and 7 position there is a dione is there, and therefore it is known as a 2,7 octane or octane 2,7 dione, you can call it as octane 2,7 dione means there are the 2 carbonyl groups are there. Remember here I am writing here as CH2 for the here you can write as a CH and 1 hydrogen atom I am writing like this, so that we can understood the meaning of this. When it is treated with dilute sodium hydroxide, OH dilute, right? And now what is going to happen, this OH minus will abstract the proton from here. So let me write first one is a product over there. Here first one, second one we are writing as a what we can call it as a this one. Heat it, what you are going to get 1 2 3 4 5 means there are 5 membered rings are there, so that you are going to get the product like this. 5 member, the bond here we are going to get this one, I think CH3 and this CH3. This type of the product you are going to get alpha beta unsaturated compound. This one is this should be alpha, this will be the beta. So alpha beta unsaturated compound is alpha beta unsaturated ketone, right? Here is a ketone, unsaturated ketone. Alpha beta unsaturated ketone we are getting. Now let us look at as a mechanism here, how we are going to show this mechanism, why these products are obtained and why it is called as the intramolecular Aldol condensation reaction, because the both the carbonyl groups are present in the same molecule and therefore it is called as a intramolecular Aldol condensation reaction. This structure, now let us look at as a mechanism over there. Just now we have seen how we are getting this alpha beta unsaturated compound CH3, this CH3 and this CH3, right? This compound. And for that, let us look at as a mechanism. Once you know the mechanism, as we know that mechanism means what? A detailed study of sequence of steps which are involved in the conversion of reaction into product is known as mechanism, right? Reaction of mechanism. And now here I am specifically writing this one CH3, then this is the carbonyl group I am writing, the CH2, one CH2, and here I am writing specifically for the sake of convenience of this C double bond O and this CH3 I am writing like this. Now first step is we are using dilute sodium hydroxide NaOH. Now OH minus, which is a base, and as we know that the function of that base which will abstract the acidic proton over here, the proton here also, which one is a more acidic? This one is a more acidic, but for the driving force over here is a formation of the, if you see over there is 8 membered rings are formed, and 8 membered ring according to as a bare strain theory it is not possible, or it is very unstable, and therefore the proton which is this one is get abstracted by this base, so that the resulting compound form is a 5 membered ring which is stable according to as a bare strain theory. And that's why here what is going to happen when that OH get abstracted, the negative charge on that carbon atom, and you are going to get here we can write this compound in this manner, so that you can understood this here CH minus charge, then C double bond O and CH3, that's it. And now what is going to happen, this negative, this is nothing but as a carbanion, right? Carbanion. This is a carbon number 1, 2, 3, 4, 5, 6, 7 and 8, right? Here also you can give the number 1, 2, 3, 4, 5, 6, 7 and 8, right? Now this negative charge is going to attack on this carbonyl group, then negative charge on that oxygen atom. What do you get? Here you can write as a 5 membered ring like this, right? I am writing 1 bond, 2, 3, 4 and 1, this one 5 bond. Here you can write O minus here like this, and methyl group you can write as it is, and this is the group which is you can write like this, right? So this is the group we are going to get over there. And now this alkoxide will pick up the proton from this water here H plus, so this OH minus can abstract proton from here during the workup, and what you are going to get, you are going to get the product here OH, then this CH3 we can write it, and then this one and this one, and this is called, this is nothing but our aldol product, right? Aldol, or we can call it as alpha beta hydroxy ketone, or we can call it as beta hydroxy ketone, we can call it, right? And after that just heat it, and after heating, look at here, one of the hydrogen from here at alpha position, it get evolved like this, and there is a elimination of water molecule, gives the alpha beta unsaturated compound over here. Double bond should be here, one methyl group, it is as it is over there, and this is also known as a chalcone or the enone system. Carbonyl group and this system also known as a enone system, and that enone system during the ultraviolet spectroscopy we are going to learn what do you mean by the enone system. Enone system nothing but as a carbonyl group has one carbon-carbon double bond adjacent to that type of the system is termed as a enone system, or that system also known as, referred as a chalcone, common name of this compound. This is alpha, this will be the beta, so this compound is known as alpha beta unsaturated compound, alpha beta unsaturated unsaturated ketone, that is the product we got over here. Understood this one? Intramolecular aldol condensation reaction. Now let me give you one more example over here. Let us see here one. Now we know that the mechanism, how the mechanisms are taking place, just now we have seen. Now let us see one more example over there which can illustrate the intramolecular aldol condensation reaction, that is a 5-keto hexane diol. So now here C double bond O CH3, then this will be the C double bond O and this aldehyde. The numbering start from aldehyde, which is more oxidizable than ketone, and therefore number should start from this side. 1, 2, 3, 4, 5 and 6 carbon atoms are there, and it will be treated with dilute sodium hydroxide NaOH. There, look at here carbonyl group, and this is aldehyde. This is something like as a cross aldol type of the reactions are there, because this is the ketone and this is the aldehyde group. Aldehyde also has an alpha hydrogen atom here. Here also has alpha hydrogen atom, which alpha hydrogen atom is going to abstract over there. That decided the formation, and as we know that 6-membered ring is preferred over the 5-membered ring according to as a Bernstein theory, and therefore this is the first point we are adding over there, and that is the second point. The reagent we are using, just as a triangle means heating, the resulting compound will be obtained as a this one. Let us see here, this is a 6-membered ring, and this is known as alpha beta unsaturated compound R1 2. This compound is known as a 5-keto hexanal. ALE indicate as aldehyde group. 5-keto at 5 position is a ketone group, and that's why it is a keto, and the name is given to that compound is a 5-keto hexanal. And we are getting as alpha beta unsaturated compound, which is a cyclohexene 3-ONE. The name of this cyclo means this is cyclohexene 3-ONE. ENE indicate as a cyclo means cycle, hex indicate as a 6 carbon atom in the ring. ENE indicate as a there will be a carbon-carbon double bond. and 3 ONE, it indicates that at 3 position there will be a ketone group, and therefore this is the IUPAC name of this compound. Now if you look at the mechanism over there, let us see how the mechanism takes place over there. Yes, I am writing that compound here, double bond C, double bond O. This compound we are going to synthesize over here. Let's see how we will synthesize that alpha beta unsaturated compound. Let us see here mechanism, and as we know that mechanism is a language of organic chemistry, and therefore let us see how the mechanism takes place over there. The substrate is this one, C double bond O, then CH2 I am writing specifically like this, so that we are getting here C double bond O and H, right? Now when it is treated with OH minus, means OH, where from this OH is coming? That OH is coming from the hydroxy group, means dilute sodium hydroxide. What it will do in the here, it will pick up or it will abstract the proton. Proton get abstracted by the base and leaving behind its bonding pair, and that's why we are going to get over here C double bond O minus charge I am putting over here, and then C double bond O H. Now we can draw the resonating structure, because this is nothing but as a Carbanion formation, right? Because all these reaction, the chapter's name itself suggests that Carbanion and their reaction, and therefore you have to mention there is this is a Carbanion, and now as we know that is forming as a double bond here, negative charge over there, and you are going to get double bond, there is a O minus enolate type of the species, and now I am writing that ketone group is like this and hydrogen atom like this. Now what is going to happen in the next step? In the next step, this negative charge coming down, forming as a double bond between carbon atom and the oxygen atom, this double bond attacking on that carbonyl group, and then negative charge on this oxygen atom, so that we are going to get this is a formation of the 6-membered ring, double bond over here, and now the O minus charge, right? And that alkoxide further pick up the proton from the solvent OH. Now hydrogen positive charge over there, this will pick up the proton like this and neutralizing the positive charge. The resulting compound will be formed C double bond O. There is a OH. This is a alpha, this one is a beta. At beta position there is a hydroxy group, and therefore it is known as a beta hydroxy ketone, and this beta hydroxy ketone, the common name of this compound will be aldol, and that aldol is a very unstable. We just give the heating, just after heating there is a elimination of water take place like this, 1H from here and OH from here, elimination of water takes place, and the resulting compound is formed is alpha beta unsaturated compound, C double bond O, double bond over here, this is alpha, this will be the beta, and now this is known as a alpha beta unsaturated ketone over there. Ketone, or the name of this compound is a, what is that? Name of this compound is a alpha beta, or 1 2 3 4 5 6, that is a cyclohexene 3ONE, cyclohexene. At this position there is a ketone group, and therefore name of this compound is a cyclohexene 3ONE. Number is starting from here 1 2 3 4 5 and 6. I think this is a compound we got, that is the intramolecular aldol condensation reaction. So in this way we have seen how the aldol condensation reaction is taking place. I think we have learned all these aldol condensation reaction. Aldol condensation reaction is according to as a nucleophilic addition reaction, right? Because that Carbanion reaction, these reactions are proceeding or occurring via Carbanion, so that there are two kind of the nucleophilic reaction. One is a nucleophilic addition reaction and another one is a nucleophilic substitution reactions are there. And so far we have seen one famous reaction, because in this particular chapter 4 famous reaction we are going to learn. One is aldol condensation reaction, another one is a Claisen ester condensation reaction, and then Perkin condensation reaction and Wittig reaction. These are the 4 reactions. Out of that 4, one we have seen with their suitable examples. Just remember as a simple aldol condensation reaction. Second one is a cross aldol condensation reaction. Third one will be the intramolecular aldol condensation reaction. Intramolecular condensation reaction is a synthetically very useful, because intramolecular reaction, they are forming as a ring over there, and that type of the ring formation compounds are very important as far as the synthetic point of view is concerned for the organic chemistry. And so in this way let me revise again that simple aldol condensation. The requirement for simple aldol condensation, 2 are the same molecule containing as a carbonyl group, and there must be as a alpha hydrogen atom, and then that type of the molecule undergoes as a aldol condensation reaction. And second one is a cross aldol condensation reaction. The requirement for that, out of that 2, one must have a alpha hydrogen atom, 2 alpha hydrogen atom, then it undergoes in a basic medium aldol condensation reaction is possible. In acidic also there, but in acidic medium we have already learned that type of the reaction in our previous semester, but here just only as a basic medium reaction we are considering, and how they are taking place. And synthetically the cross aldol condensation reaction is preferred over that because there one of the compound which containing as alpha hydrogen atom, now let us, and we are getting as a simplest one. Now let us look at here some of the example. You just have to tell me what type of the reaction they are. Let us see some of the example, whether you understood this. All these aldol condensation reaction are not. Let me know, suppose we have this compound, suppose we have this one, CH3, then C double bond O, then CH2, then CH3, that will be treated with, suppose let me take here is this one, C double bond O and H, that will be treated with. First one is a dilute sodium hydroxide, and second one will be the heating process. What will be the product? And first tell me, does this reaction undergoes aldol condensation reaction? Yes, it undergoes as a aldol condensation reaction, because one of the carbonyl compound has alpha hydrogen atom. Look at here, first compound, it has a alpha hydrogen atom. How to identify alpha hydrogen atom, whether they are has alpha hydrogen atom or not, you look at carefully the carbonyl compound, because aldol condensation reaction given by the carbonyl compound, and as we know that carbonyl compound referred as a aldehyde or the ketone, because carbonyl group is present common in both aldehyde as well as ketone. Look at, one is a ketone, another one is a aldehyde, and aldehyde here, this is the this is the crossed aldol condensation, and synthetically is very important, because the resulting compound is going to obtain only as a one product, single product. Why? Because only one of the molecule has a alpha hydrogen atom and second molecule do not have a alpha hydrogen atom, and this reaction going to show the aldol, cross aldol condensation reaction, and the resulting product formed will be like this. Let us see here, over here there, in short I am writing the, or let us see here, we can write as it is, this one CH, then double bond CH, C double bond O, then CH2 or the CH3. This type of the product you may get. Another product may be possible if you form as a carbanion. There are two acidic protons are there. Let us see, adjacent alpha hydrogen atom, and among this which one is a more acidic in nature? Ultimately remember, this one is a more acidic one, and those are the highly acidic in nature. The base prefer to proton, more acidic proton readily or easily form the carbanion, and that carbanion is well stabilized due to the resonance, form the enolate ion, and that enolate ion are more stable as compared to as a carbon, and that's why they are get stabilized, and that carbanion is going to attack on the carbonyl carbon of the second molecule, and the resulting product form is the aldol. That aldol further eliminate the water molecule and gives the alpha beta unsaturated compound. This is known as a enone system, or it is known as a chalcone, is a common name of this compound. That's this. Now suppose, let me see over there, suppose you have this compound, let me check your C double bond O, then CS3, another again is a taking as a C double bond O CS3, and I am taking as a first one is a dilute sodium hydroxide NaOH, second will be the just heating. What will be the product you are going to get over here? Look at these two. What is the IUPAC name of these two compound? The IUPAC name of these two compound are acetophenone, as we know that. Acetophenone. Does this molecule acetophenone, does this acetophenone undergoes aldol condensation? Yes or no? Yes, they undergoes as a aldol condensation reaction. What type of the aldol condensation? Because there are the three different aldol condensation reactions are there. One is a simple aldol condensation reaction, second one is a cross aldol condensation reaction, and third one is a intramolecular aldol condensation reaction, and therefore this is the first which one? Simple aldol condensation reaction, and the product is going to form over there. In short I am writing, or let me draw this reaction once again. Then here I am writing as a CS3 double bond, then here CH, then C double bond O, and then this phenyl structure over there. So this is the alpha beta unsaturated compound, or which is known as a enone system. That enone system, while studying as a what we can call it as ultraviolet spectroscopy, we will see over there the detail of that enone system, how it is, why it is called as a enone system or the chalcone. So this is there. Now let me give another one example. Suppose you have this type of the compound. Let me draw over here. Suppose 1 2 3 4 5 6 7 8 8 no 8 this type of the compound, and that will be treated first with a dilute sodium hydroxide, and second one will be the heating process. Heat it. So just let us give number 1, 2, 3, 4, 5, 6, 7, 8 and 9. So here 1, 2, 3, 4, 5 and 6. So that if you do this, you are going to get the product over here. This type of the product you may get over here. This one. This alpha beta unsaturated compound, and they are both 6-membered ring. This is a alpha beta unsaturated compound. What type of the reaction it is? It is a intramolecular aldol condensation reaction. I think with this we have seen the one intramolecular aldol condensation reaction with the some of the suitable example. Let me give one more example so that you can, whether you are knowing this reaction is a very specifically or not. Let us see one more reaction over here. Suppose you have this one CH3 C double bond O CH3, and another one maybe as a CH3 then CH3 C double bond O H, that will be treated with first one with a dilute sodium hydroxide NaOH, and second will be the just as a heating. You have to, what is your job over here? Your job is to predict the product. If how do you predict the product? And when you are knowing the mechanism behind it, then and then you can able to predict the product. Otherwise it is very difficult to predict the product. So here we already know that does this molecule shows aldol, does this molecule undergoes aldol condensation reaction? Yes, it undergoes as a aldol condensation reaction, because there are two carbonyl compound and one has a alpha hydrogen atom, and one of them is not having as alpha hydrogen. Two different molecules are there, and therefore it is a cross aldol condensation reaction, and the resulting product must be the single product we are going to get over here. And the product, which one product you are going to get? The product you are going to get here CH3, then CH3, CH3, CH double bond, then here CH3, then C double bond O, and the CH3 acetone 1, 2, 3, not this one. Here the carbanion is formed over there. So let me write CS carbanion CH3, then here CH3, then CH double bond C, then CH3, then C, I think this one CH, not here, CH, then C double bond O, and that's it. I think, yes, this is alpha and beta, because carbanion is going to form over there and this is going to attack over there, and after heating you are going to get as a alpha beta unsaturated compound. Look at the number of carbon atoms here, because this is a aldol condensation reaction. Two molecules get condensed there. 1, 2, 3, 1, 3, 4, 5, 6, 7 and 8. 1, 2, 3, 4, 5, 6, 7 and 8, and therefore it will be the correct product of that aldol condensation reaction. I think with this we have completed as a aldol condensation reaction, and tomorrow we will see the Claisen ester condensation reaction. I think with this let us stop today here. Have a nice day. Thank you.